Namaste Connections. I am Praavinya, and recently I had the opportunity of presenting a graded seminar on the topic YouTube, how it works. So these are the table of contents that I shall be covering today. Introduction. What is YouTube? YouTube is a transformative digital online video sharing platform that has fundamentally altered the content consumption patterns and has become a crucial component of each and every one of our lives. Every one of us use YouTube for various purposes, and it has significantly become an important part. YouTube was launched in 2005 and is currently the world's largest video sharing platform. Now, YouTube functions through a combination of user generated content and algorithms to personalize the video recommendations. I shall be focusing on how the users get recommended videos according to their personalized taste in this seminar. Next. This is a brief history of the YouTube algorithm, and it just shows a glimpse of how the timeline was and how YouTube algorithm has evolved over a period of years. So from 2005 to 2011, the videos were basically ranked on the principle of view count. That is, higher the number of views in a video, higher would be the pop-up of the video. But there was a problem. There was a problem of clickbait. That is, the video thumbnail and the title would show something else, but the video would be completely different. Next, in 2012, there was the concept of watch time, which is introduced. Now, watch time is basically the total duration for which a particular user or an average number of users for an audience of a video, of a particular video, sit and watch the video. Next, in 2016, we had the concept of machine learning, which was introduced. By 2016, we already had features like, share, subscribe, comment, and etc., which were already introduced and which are still used in YouTube. So the machine learning algorithm basically used all of these, that is the user interactive methods of liking, sharing, and all that, and they used all of that as the previously stored content to give the recommendations to the user. Next, in 2020, we did not have a very highly new change for the algorithm, but there was a method which was introduced to reduce the clickbait. That is, if you hover your cursor on the video thumbnail, it would show a glimpse of the video. That is, if a video is actually what the thumbnail was showing or what the title is about, or is it something different? Next, currently, from after 2020, we are using a combination of all these complex signals to give the personalized recommendations to each and every one. This is what I have explained just now. Next, we have the YouTube homepage. So this is how the YouTube homepage looked like in 2005. As you can see, it's a very basic homepage, and only five videos are seen as of now. And you can see that there are watch more videos over here. This is what the YouTube homepage looks like today. Okay, how does YouTube gather data? First, user behavior. So the YouTube algorithm analyzes the user interaction with the videos they watch to understand the user preferences. Next is search queries. So the YouTube algorithm considers what the user search for. That is, the users would be more interested in the content they are manually searching for. And once you search it manually, the YouTube algorithm will automatically show you videos related to that from the next time. That is, it tailors recommendations to their or your choice. Next is engagement. So the YouTube algorithm looks at the video performance data like watch time, shares, likes, comments, and etc. to gauge the content quality. That is, more would be the engagement, more would be the recommendation along with that video. Demographics. Okay. So for using YouTube, as we all know that YouTube was acquired by Google in 2006. So from then, YouTube is a subsidiary of Google, and you cannot use a YouTube account without having a Google account. That is a basic Gmail account. So when you make a Gmail account, the Gmail account asks you for basic information like your age and location, etc. So all of that is combined in the backend of Google, and YouTube accesses all that data, that is the demographic data, to give you recommendations according to your choice or according to the demographic data. So if your age is, say, if you're a college student and if you're 18 or 19 years of age, then YouTube would tailor recommendations to your age. That is, Probably he would give you student-related content or university student-related content to be more precise. Next is collaborative filtering, which is an algorithm which I will be discussing right now. But basically, it examines the patterns from similar users to suggest videos that are comparable, that are with comparable taste. That is, it compares the taste of two or more users to again align recommendations to their choice. Okay, why do recommendations matter? So first, user engagement. If the videos are personalized according to the user's taste, the user would sit and watch it more. That is, it would increase the watch time, user interaction, and also the retention rate, which is the third point over here. So the user engagement and retention rate is what I've discussed right now. Second is content discovery. It helps the users find content that aligns with their interest, thus enhances the user satisfaction. That is, if you are watching something and probably if the YouTube algorithm suggests you a similar video to that, it might be very possible that what you would like the recommended video more than what you're probably watching right now. So that is content discovery. You are finding better content because of the YouTube recommendation. Next is the revenue generation. So YouTube provides us with the facility of revenue generation. And if there are more views on the recommended videos, it would be a plus point, a win-win for both YouTube as a company and the content creators. So if there are more views on the recommended videos, it would translate to a higher ad revenue for both the parties. Next is community building. If you have videos recommended personalized to your taste, if you would watch the videos, you would find that in the uh, comment sections, or you would find the users like you who are interacting with the videos. So basically, that would make a community connecting like-minded people. So that would again be community building. Next is the diverse content promotion. YouTube recommendation system encourages the exposure to a variety of content, helping not just popular people or popular content creators gain visibility, but also the small creators. There are a lot of small creators who gained visibility because of the YouTube algorithm system. Algorithms used. So YouTube algorithm or the YouTube recommendation system or the recommendation system in general is a combination, or it has many machine learning algorithms here, which I've mentioned 9 of them. I will be discussing two in detail. That is the collaborative filtering algorithm and matrix factorization technique. Moving to collaborative filtering algorithm. Now, collaborative filtering algorithm is again divided into two parts. That is the user-based collaborative filtering and the item-based collaborative filtering. So the user-based collaborative filtering is a technique to predict the user's interest by aggregating preferences or viewing patterns from multiple users. Okay, let's consider an example. Here we have user 1. User 1 and user 2 both are different users and have no connection to each other. Let's say both of them have watched two videos which are the same, video 1 and video 2. And coincidentally, both have the same views about the same videos. That is, both user 1 and 2 have liked video 1, and both user 1 and user 2 have disliked video 2. So let's say user 1 is watching a third video, video 3, which user 2 has not watched yet. But there is a high probability that whatever would be user 1's viewpoint regarding video 3 would align to user 2. Since user 1 and user 2 have already aligned interest in their past, so this data would be stored in the YouTube algorithm. YouTube would store this data to recommend. That is, it would store it in the backend that both of them have liked this particular video and both of them have disliked this particular video. So then that would be previous profile history of both the users. And so when user 1 has watched the video 3, it would automatically get recommended to user 2. Next, we have item-based collaborative filtering. This is a similar technique to user-based filtering, but except here, it focuses on the relationship between the videos rather than two different users. So let's say there's a user who has watched two videos, video 1 and video 2, which is of the same genre. Let's say both of them are stand-up comedies. Now, since he has watched two stand-up comedies and has interacted with the videos in any way, let's say he has liked or commented on those videos, and then there is a third video, which is also a stand-up comedy. And since he has interacted with the other previous two videos, there is a high probability that the YouTube algorithm would recommend the third video to the user because it is of the same genre. So this is how item-based collaborative filtering works. Moving on, we have matrix factorization technique. Okay, so what do we understand by factorization? Factorization in basic simple terms is basically breaking down anything into two parts. So matrix factorization is decomposing a matrix into smaller submatrices such that when all these submatrices are multiplied together, they either give the original same matrix or give us approximately the same matrix. Now, by decomposing the user item matrix, these models uncover latent factors that represent the user preferences and item characteristics. These latent factors could be anything. And during the initial stages, the YouTube algorithm takes some time to uncover these latent factors. I'll come back to that later. Now, of course, matrix factorization technique helps generate the personalized recommendation by predicting how users might respond to unseen or new videos based on their previous preferences and past behaviors. That is, the YouTube algorithm would save the past profile history of the user. And matrix factorization technique is a prominent algorithm for collaborative filtering. So let's take a case study for matrix factorization. Consider there is a YouTube recommendation system for 3 users and 4 videos. Now, based on the implicit feedback, let's say watch time in this case. So there are 3 users, U1, U2, and U3, and there are 4 videos, action video 1, action video 2, comedy video 1, and comedy video 2. Now we observe that not every user has interacted with every video, which is why we have these missing question marks over here. And our goal is to predict these missing question marks. So these missing question marks are basically the missing watch time. Let's also consider that in this example, all the three users have just created a YouTube account. That is, they have no previous past history and they have not watched anything yet. So user 1 has watched 2 videos, action video 1 and action video 2, and has not watched any other video, and same for the others. So first we would define the latent factors, and here the latent factors are the preferences, that is the action preference and the comedy preference. So we would then make user latent matrix and an item latent matrix. So, okay, we are going to initialize the user and item matrices very randomly. That is, all these values over here, which you can see 0.6, 0.7, 0.4, and all these values have no connection to the previous values here, like the 10 minutes, 8 minutes. These values are completely random. As I said, that the users have just started a YouTube account and have no past history. So these values are completely random. And so in the initial stages, these values might give us the correct answer or might not. So now we are going to dive in deep into it. So if we see, we are going to predict the user's watch time by multiplying a user latent matrix with an item latent matrix. So let's say we have to predict the watch time of user 1 for action video 1. Although it's given here, let's say we have to predict that. And we don't know that the user has already watched it for 10 minutes. So what we are going to do here is we are going to multiply U1 with action video 1 in both the cases. That is for action preference and comedy preference. And we are going to add all of it. So it would be 0.6 into 0.9 plus 0.4 into 0.1. And after adding all of it, we would get the answer as 0.58 minutes, the watch time of it. But we see that 0.58 is nowhere even near to 10. So then comes the error computation. What is error? In very simple terms, error is actual watch time minus the predicted watch time. So the error for U1 for watching action video 1 here would be 10 minus 0.58, which is 9.52, which is the very large error in this example. So since the error is quite large, we would say that since the values were very random, the values in the user latent matrix and item latent matrix were very random, and since there was no previous past data, this is why the error is quite large. And this is very common in the previous and early stages of the matrix factorization. But as we continue to make the iterations, the values, that is the latent values, would keep adjusting by each step, and thus the prediction process would keep refining. So there is no set number of iterations, but I would say if you continue to keep doing the iterations. That is, the process basically depends on how long you give the platform the time. That is, the longer you spend time on the platform, the more better it would understand you, since it works on machine learning. So the more time you spend on the platform, the more it will understand you, and the more it will understand your preferences to give you tailored recommendations to your choice. So this was about the case study, and similarly, we can calculate it for the other users also. You can also give it a try. Then the challenges and limitations. So there are three major challenges or limitations to the YouTube's recommendation system. First is data scarcity. So there is a lack of sufficient interactions for new or niche videos. Niche videos here are specialized videos which are different to the common or mainstream videos. Say, for example, someone is pursuing a degree in wood crafting. So wood crafting is a very specialized course. Not many people do it. So any videos related to wood crafting would be would be less popular. So they are niche videos, and since they are less popular because of their specialized behavior, they would be hidden, and that would be uh, this thing a disadvantage for the YouTube recommendation system, since it would not recommend it to many users. Second is scalability, that is handling massive data volume for real-time recommendations. So every day there are millions of YouTube videos which are uploaded on the YouTube, and uh, handling all those new videos and all the videos uploaded, everything, all the data is quite difficult. So there are a lot of times when we get YouTube recommendations after 2 or 3 days of uploading the video. Next is bias amplification, which is a very important point. That is, most of the time, the YouTube algorithm, the YouTube recommendation system promotes sensational content. That is the content which has more engagement, the more likes, more watch time, more shares, or anything like that. And thus, it prioritizes engagement over quality. Those videos actually might not be that good, but since they have so much engagement, they are actually getting more watch time, and they're getting more views, and they're getting more recommendations. So these are the limitations. Okay, coming back to the conclusion, the YouTube recommendation system plays a crucial role in enhancing the user engagement and content discovery. And by using algorithms like collaborative filtering and matrix factorization, it personalizes the video suggestions and tailors it according to users' taste. But then again, that requires time, and because it's machine learning, that will again be a slow process. Despite the challenges like data scarcity, scalability, and potential bias, the system continuously evolves to improve the content, relevance, and user experience, ensuring both the creators and viewers benefit from personalized dynamic recommendations. And these are the references that I had used. Thank you so much for listening, for giving me time, and I had fun doing and presenting this seminar. Thank you.